Right, we're going to have a look now at a couple more graphs. And in this lesson, the rectangular hyperbola and the truncus are going to be looked at. We're coming off having looked at some quartic and cubic curves and some translations of those. Now, in this lesson, we're going to look at two types of graphs. Two types of graph, the hyperbola and the truncus. So first up, the hyperbola, the rectangular hyperbola, to be precise. There are other types. We're looking at the rectangular hyperbola, and it is the result of examining the relationship between y and x when y equals rectangular hyperbola result from the graph of the function y equals 1 over x, or in fact, if we're being more general about it, a hyperbola will result when we have x in the denominator. That is the key thing here. Having an x in the denominator really does force the shape of this curve, and you'll see in a moment when we have a look at the values. Okay, so if we wanted to start by, and it's often a good idea just to have a look at what are the points here that make up this this curve, because obviously there's, whenever you look at a relationship between y and x, there's an infinite number of points. So what we want to do is get an idea of, what does this thing look like. So if we just take a few points either side of 0 and see what's going on. If we start up here with 3, well, that's y equals a third, so that's fine. Put 2 in there, y equals a half. 1 in, y equals 1. 0 in there, 1 over 0. Whoa, 1 over 0. That's an issue, and that's a key point. Put in minus 1, 1 over minus 1, that's minus 1. 1 over minus 2 is minus a half. 1 over minus 3 is minus a third. See what's going on there. Let's take a look now at this curve. Just over here, in fact. Just have a look at that. That's my x-axis, that's my y-axis. And okay, so right, if we go over to, so 1, 1, that's easy enough to plot. As we go 2, a half, 3, a third, I get this, 4, a quarter, 5, a fifth, it's getting small. Okay, what happens in here when x is a half? I didn't put one of those points down, but I can't stop there. And what's happening? It looks like it's taking this shape, but when x is a half, all right, well, can we just do a little calculation of y equals 1 over, when x is a half, it's 1 over a half. How many halves are in 1? It's 2, isn't it? So when x is a half, y is 2. So as x gets smaller, let's put a tenth in. How many tenths are in 1? That's 10. As x gets smaller, a tenth, y is getting bigger. And as x is getting bigger, y is getting smaller. But, very, very importantly, it's never going to actually reach 0. So my values of x or y are never going to reach 0. Right, we've talked about this. X can't be 0. So I can get really, really, really small, and that's going to make y really, 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 really small. Sorry, x can't be 0. So as x gets really, really, really small, y is getting hugely big. And as x gets large, 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 as it goes down here, 100 million, y is ridiculously small, but never 0. So these two never touch the x-y axis because they can never equal 0. Incredible. Okay, what happens over this side? Minus 1, minus 1. Oh yeah, minus 2, minus a half. Minus 3, minus a third. Looks like the same sort of thing's happening. Put minus a half in here. I'm going to get minus 2, minus a third. Yeah, it's doing this, isn't it? But it's doing it in this quadrant. So it's got that sort of shape going. So this is the rectangular hyperbola that results from y equals 1 over x. A quick look at what would happen if it was y over 2x. Sorry, 2 over x firstly. 2 over x would head out this way. Because if it was 2, let's just have a look at y equals 2 over x. Well, when x is 1, y would now equal 2, whereas it was 1 there. So just, everything just shoves up a little bit. So it would just be above the green there for y equals 2 over x. And it would be that sort of thing there. And then if we have a look at, so it's punching out that way, if we look at y equals, say, 1 over 2x, so the adjustment is made down here for the 2, that would make, when x is 1, y is a half. So now we're tucked in down here. And so that would be y equals 1 over 2x. So if I color code this, the green is y equals 1 over x, the blue is y equals 2 over x, and the red is y equals 1 over 2x. Okay, so you get the movements there, just shoving around a little bit. X and y, I mentioned the asymptotes. These things, or maybe I didn't, these things are called asymptotes. These lines, the x and y axis in this case, axes, are asymptotes because I've had enough of green. Too much green. I'll go back to red. These are, come on. These are called asymptotes. Right, so lines that act as like buffers. You know, there's this curve never crosses it. It just sort of buffers it. It holds it in. That's an asymptote. That's a horizontal asymptote. The x-axis is a horizontal asymptote, and the y-axis here, it's a vertical asymptote. All right, there's a new word for you, asymptote. Maybe it's a new word. It acts as a buffer. The curve can never touch it, never reach it. Brilliant. Okay, what happens? Let's keep in mind those asymptotes, really important. What happens when we, well, let's just change this around. What happens if it's y equals minus 1 over x? Okay, well that's gonna stuff things up badly, isn't it? That's gonna change everything around here. So what would happen? What would happen if, let's say, you go up to these values here, still 0 is a problem? Yes, it is. Let's start to just have a look. What happens? So this is my x, this is my y. So we're just having a look at what happens to 1 over x when it becomes minus 1 over x. Well, now for my x values, when x is 1, now this is going to be minus 1. So when x is 1, it's now minus 1. So it's down there somewhere, right? When x is 2, y is minus a half. X is 3 minus a quarter, x is 4 minus a quarter, x is 5 minus a fifth, etc. When x is 1 half, y is going to be minus 2. So it's going to go down like that. So it's going to, for x positive, it's going to be in there. What about x negative? X negative, put in minus 1. Minus 1 over 1, well that's now positive 1. So minus 1 goes to positive 1. Minus 2 goes to positive a half. Minus 3 goes to positive. See what's going on here. Minus a half goes to positive 2. This is my minus 1 over x. So these are my negative quadrants for the hyperbola, and these are the positive quadrants. Okay, one more thing to consider with hyperbole. We'll talk about asymptotes. What about when y is equal to, and we're going to take 1 over, I'm going to say this is x minus 1. What happens there? So we've changed our denominator around. Is our asymptote going to change? So now the asymptote is driven by what x and y can never ever be, no matter how hard you try. What in this case is a problem? Well, when x equals 1, we get 1 over 0, and that can't happen. So x equals 1 is now my vertical asymptote. There we are. It goes through 1 here on the x-axis, because x can't be 1. So now my hyperbola would be there, because it's positive, and there. It would look like that. But I'm going to do something else. I'm going to add 2 on the end here. So what that does is now that bumps my horizontal asymptote up from the x-axis up to y equals 2. So this is now my curve. My asymptotes are in place. Asymptotes, remember, the buffers. They're like magnetic lines. You know, this curve can get close, but it's just going to be holding up. It's not going to quite get there. Because it's positive, it sits in this and in this quadrant. So it just goes like that. Or we can find out what the y-intercept is by putting in x equals 0. 1 over minus 1. It's minus 1 plus 2. Well, that's 1. Great stuff. My x-intercept is where y equals 0. Slightly more difficult to calculate. 1 over x minus 1 here will equal minus 2. So minus 2x plus 2 equals 1. Minus 2x is equal to 1 minus 2 is minus 1. X is equal to 1/2. So we quickly worked out there that my x-intercept would be 1/2. So, but what I really want you to get out of this is that when we mess around down here, if we add or subtract something in here, then that's going to shift horizontally our asymptote. So it starts off here. The minus 1 means it shifts right by 1 to a new asymptote that goes through x equals 1. And the plus 2 on the end here, well, that pushes our horizontal asymptote up to 2. And that's the hyperbola. Okay, let's move on. You haven't got all night, and we're now going to have a look at the grandly named the truncus. The truncus. What a fantastic name that is. So this results. What did I write up here for hyperbola? The result from the graph of the function y equals 1 on x. Well, the truncus results from the graph of the function y equals 1 over x squared. Wow, okay. Let's just try and contain your excitement here, because what we're going to do now is we're going to have a look at what happens when we try and look at the points that where y equals 1 over x squared. So, right, let's again have a look at a few points left and right of 0. Minus 1, minus 2, minus 3 in there. Right. Okay, again, what an issue we've got with 0. Can't do it. Can't do it. So, little question mark in there. I'm confused. 1 over, right, so for x equals 1, 1 over 1 squared is 1. 1 over 2 squared is 4. 1 over 3 squared. Am I getting this right? I'm not getting this right. Someone stop me. That's not 1 over, let's get rid of that. 1 over 2 squared is 1 over 4. 1 over 3 squared is 1 over 9. Back this way, 1 over minus 1 squared. In square minus 1, you get 1. Square minus 2, you get 4. So that's, oh, hang on, we're getting the same results over here as we did here. So what does that mean for our graph? I think what it means is that we're going to get this little reflection in the y-axis. So we've still got this problem at 0, 1 and 1, 2 and a quarter, 3 and, oh wow, it's getting really low really fast. What about it like a half? X equals a half. Half squared is a quarter. 1 over a quarter is 4. So yeah, it does. It goes like this. So we've got a similar looking thing to 1 over x, where we've got this asymptotic graph. Asymptotic, do you like that? We've got asymptotes everywhere. Asymptote on the x-axis, meaning the curve gets closer to it, doesn't reach it, doesn't touch it. And an asymptote here on the y-axis as well. Make a note of that. Asymptote. Asymptote. Alright, but what about on the negative side? Minus 1 also goes to 1. So it reflects in the y-axis. So my truncus is going to be something like that. Don't know why it's called a truncus, but I love the name. So that's our truncus for 1 over x squared. Well, okay. What would minus 1 over x squared be? That would be a reflection then in the x-axis. So I'll color code it so that we can quickly draw it in. This is going to be minus 1 over x squared. Y equals minus 1 over x squared. I hope you're getting all these notes down. And finally, we're going to look at what happens when we take y equals, we'll just take 1. We'll move it across 1 and down 2 in this case. So again, have a look at our truncus its shape will stay, but its asymptotes are going to move. The +1, what does it mean? It means go 1 to the right. So we go through 1, and the -2 means go 2 down. So 2 down horizontally through -2. That splits our curve up. Now we're going to draw our truncus through. It's positive, so it's above the asymptotes. And it's through there, and we create a couple of points of intersection here quickly. If x is 0, 1 over 0 plus 1 squared, 1 over 1 minus 2, that's -1 in there. The x, well, that's going to be more difficult because it's squared. It's going to be a square root setup, and I'm not going to go into that now. So that's the translation for the truncus, and I think we better pull up there. Your work then for Tuesday will be on exercise 5A and 5B, and that will be from the work requirements. Excellent. I'll see you shortly.